So today might be a little bit of a repeat from an earlier class or something you guys have already done, but I think this will be a good way to make sure that everyone's on board and everyone kind of fully understands the parametric capabilities of working within the project environment and then also in the family environment, because there's kind of this, I think once we got into the project environment, a lot of you are kind of having some issues with what to do in there and how to place a bridge. So what I want to do is start with a project environment, and we'll kind of work back into the family environment and vice versa. Any immediate issues you guys want to just throw out there at the moment? Or I know a lot of you have emailed me certain problems, but it sounded like a lot of you had problems with the actual placement of the bridge on the site and trying to get it to be parametric. I'm going to show you a couple ways of actually modeling within the project environment where we can just get a simple walking path, but it's going to be using some of the basic tools of Revit, and it's not going to be parametric. Then I'm going to show you how we can take that and work back into our family environment and actually set up our parametric values. The kind of point of this whole part one of the semester is, you know, we could have created probably a bridge by now that wasn't parametric, that we could just apply to you know, any kind of site. But one thing that comes up during project development, especially when you're in the office, is that the client changes their mind on maybe, let's say if we had a client for a bridge, exactly where this bridge should be located. Site constraints could change, or we might decide that we want to create a prototype that could actually be applied in other situations. So what if you decide later on that you don't want to place your bridge where you originally located it, and you wanted to move it further up the river or further down the river or on a completely different site? How would your actual architecture adapt or change so that you could place it on these other locations or these other sites? One thing would be, well, you would just model it all over again. And so for every time you decide to change a location or put it somewhere else, you have to spend, you know, hours and hours remodeling your whole entire bridge. But if you set it up parametrically, that has a set of rules that are already established with it, your set of parameters, then it's primarily just changing your parameters, and then your bridge is conforming to your new site or your new location. So that's kind of the goal and what we're trying to establish at this moment. Any other quick problems? All right. So if we can, make sure you have your project open, and you want to open the file that's called Bridge Tutorial Project File, and it'll say Site Model. I also trimmed down our site quite a bit so that we can actually work with it. Something you might want to think about as you progress on finalizing the destination of your site. I basically edited my surface, so I clicked on the surface and I said Edit Surface, and then, you know, when you get into that mode, you have a bunch of dots everywhere, you know, all the different topography, datum points, and I just deleted a whole, you know, sections of it. Or another method is you could actually go back into the CAD file before you actually bring it into here. Let's say you bring in the CAD file into AutoCAD or even into Rhino. Just go ahead and trim down, you know, a whole section of your site so that maybe you only have a little segment to work with instead of the whole entire thing. Just an idea of how we can speed up some of our workflow. When you open up this file, what you'll see is I deleted in the project browser, I deleted level 2. Remember, whenever you open up a project file in the project environment, by default you have a level 1 and a level 2 for the floor plans. I deleted level 2, I kept the site, and I changed level 1 to read datum 00. So I just renamed it. Basically everything that we're going to do is going to be based off of level, or this datum 00. Instead of doing all of those level datums like we did in the last class, where I set up, you know, we originally had level 1 and then we moved it up to 647 feet and so on. A lot of people got confused on that whole step and how to work with your bridge on that. So if we keep everything relative to this datum 00, And we've got all of our spot elevations that when we take a spot elevation somewhere on our site, that's also going to be relative or basically relative to datum 00. So this is 651 feet from this datum. I have drawn in some what I call sketch or construction lines, which are all done by using the annotate tab. And I'm using the detail lines. I made a couple different points, and I made a couple different curves, and then a line that actually takes you from the beginning of where I want the bridge to start and the end. Now I'm doing this just so we have something that's relative to the site and something that we can plan out before we actually start to build this bridge. I also struck a bunch of different dimensions to all of these different points. What you see in parentheses down at the bottom, so anytime you double click on a dimension string, you can add notes above, kind of a prefix, suffix, and then below. What I did is I made a ratio. I already figured out the ratio using just a calculator of where this point is in relationship to the overall length. So this point isn't quite in the middle or the center, even though it was snapped to the center line of this arc. Where it occurs from point to point is actually slightly off center. So there's a point 502 and a point 498. On this side, it's relative 0.487, 0.513. That would be similar to when you place a point on a reference line, and we talked about that normalized curve parameter. That can only be somewhere between 0 and 1. That's basically that same ratio. To simplify things, we might just make those equal for now. The other thing is I did kind of an overall length, and then same thing with, there's a curve 1 and a curve 2. I also labeled all of the points just for reference, calling this a curve 1S for start. This is the curve 1 point for a midpoint, and then its end, and then same thing for curve 2. These will be parameters that we're going to access or utilize in the family environment. So right now we're in the project environment. We haven't done anything with families. When you're in the project environment, we could just build a floor. You could go to Home, click on Floor. Go ahead and everyone do this. We'll get into a sketch mode. And I could just build a floor that would actually follow this sketch curve that I've already created. So I've kind of sketched this on the site plan. If we are in Home, we clicked on Floor, one of the drawing tools is actually called Pick Lines. Instead of before we've been doing things like draw lines, and you'll notice that there isn't a spline through points, but there's a spline that creates a spline relative to certain points. So this is more like a control point spline versus a spline through points, which means if you were to draw this spline, it might not actually touch all the different points along the curve. A lot of times I ignore that whole command because you definitely want your spline or your lines to actually go through any kind of control points that we can actually manipulate. But for the floors, let's just use the Pick Lines command. And if you pick the curve, you're actually drawing a purple line. It's hard to see up on the screen, but when you look on your screen, it should be a purple line that's being sketched on top of that line. I'm using that as like a center line to the bridge. And we can use the offset command. And I'm going to offset a value, let's just say 25 feet.
Side control.
Yeah. Odd place for it. Anyway, so I've got a 25 foot, and I'm going to keep the copy checked. And then if you just hover over that line that you just drew or picked, do an offset on either side. And you should be able to see kind of a dashed line to tell you where it's going to offset. And then I'm going to delete those center lines.
You did that with the spline tool?
No, I just did that with the pick lines. So you see there's a, because I already have a line that's already been drawn or established, I already drew this construction line. We can use pick lines, and you can also use pick lines if, let's say, you even bring in a CAD file. Revit will recognize the individual lines of a CAD file, and you could almost kind of trace over a CAD file if you wanted to as well using pick lines. And then I did the offset, got the 25 feet on either side. And in order to create a floor, we have to close the shape. So at the end, I'm going to actually use just the line command. And we're going to draw and make sure you snap to the endpoints on either side. And when you're done, you can hit this checkbox saying that you accept the changes. And you'll exit out of the sketch mode, and then you're not going to see your bridge that you just drew. Reason for that is if you click on the 3D views and then go into 3D, you'll see that your floor is actually down, or this bridge path is actually down on level datum 00. That's because everything that we draw is going to be relative to that work plane. You can see when you click on the floor and you look over at its properties, it says the level, its constraint is datum 00, and then its offset from 0 foot is actually on 0. If we click back in the site view, I also have already put in some actual spot elevations. If you remember from last class how to draw a spot elevation, basically in that annotate toolbar, and I just drew a spot elevation by picking, exactly where that point is, and it read the 3D information directly from that topography surface. So I've got one point at the start is at 651 feet, and then the other one at the end is at 642 feet 4 inches. What we can do is go back into our site view and click on wireframe so that we can actually see through the site and be able to select our floor. I'm going to click on the floor again, and we can edit the boundary of that floor. So anytime you draw a floor, you basically have drawn a generic 12-inch floor slab that is only going to follow, is basically just an extrusion up from your sketch lines. At any time, you can click on a floor and you can hit edit boundary, and it'll take you back into the sketch mode. So this is where we can edit and be able to select our individual lines if you wanted to change something. But you will see that there is another set of commands over here that once we get into the sketch mode, one is called boundary line, we've got slope arrow, and then we have span direction. If we click on slope arrow, and I'm going to draw basically a line that traces, well, we can do it two ways. We can either draw a line that traces this diagonal that catches the start point, connects the start point to the end point of the bridge, or we could pick that line. So we could probably just pick it, since I've already established that line. And if you zoom into one of the ends, on mine, oh, it's hard to see it here. On mine at the start point, you should see kind of this arrowhead on your slope arrow that you just drew. If you don't see it on the start, it might be on the other side, but if we're all using the same file, it should be right here. That is the head of the slope, and the other end is called the tail of the slope. If we click on that line again that we just drew, so I've got the modify tool, and I'm clicking on the slope arrow sketch, you should see in the properties that you have constraints for that slope arrow, and it will say level at tail and level at head. Everyone see that?
What's the thin line setting in this?
Just up at the top here, if you just turn on your thin lines,
I see it.
yeah, that'll actually you're turning off the thick lines and making everything thin. That will make it so that when you zoom in, you don't have a whole lot of thickness on your line weights. Where's everybody stuck at?
I don't see the double lines. It's at the start point.
So if you don't see the arrow, you might have to zoom in at the, you should be near the point that says curve 1_s. And then what you want to do is select that slope arrow so that you actually have these constraints that show up off to the left. It should say specify height at tail, level at tail, height offset at tail, level at head, height offset at head are your built-in constraints. Now what we can do is set, when we say specify level at tail, it says default, but go ahead and select the down arrow. You just click in that white space next to level at tail, and then select datum 00. And you're going to do the same thing at level at head. So we're basically saying that the reference point at the head and the tail of this slope arrow are going to be right now at the datum 00. Now the easiest way to bring this bridge up to our topography surface is because we already know our end point and our start point, and then we also know the spot elevation. We can say that the level at the head is the arrow, so that's at the start point. Height offset at head should be the 651 foot spot elevation. So type in 651 feet. And the height offset at tail will be the 642 foot 4 inches. We can hit the checkbox to close out of this floor. And then we can turn on our shaded view, and you should be able to see your bridge now in this particular view. And then also if you click on the 3D view, you can also see that this bridge is now spanning from one level to the other and hitting at the right spot elevations.
Jeremy, it doesn't matter which side is the arrow as long as you do the elevations, right?
Right, yeah, so if your arrow for the slope ended up on the other point, it's just, you just need to make sure you're at relative, you switch your points around for different elevations. So that is a quick way to build a path that stretches across in any topography from one point to the other. So your floor should be actually sloping consistently all the way across from that one spot elevation at the start to the spot elevation at the end.
And what were the heights of the offset at tail and head again?
If you zoom in, you should see those spot elevations, but the start was at, assuming that your arrow was at the curve 1S, it's at 651 feet, and at curve 2 endpoint is, or the tail is 642 feet 4 inches. Now that's the quick way to draw any kind of floor within Revit. The problem is Nothing about this floor is parametric. Whenever you draw in the project environment, you are essentially drawing kind of one-off items. And once you get into the family environment, you can actually start adding parameters and then making things parametric. So the point would be, let's say you decide later on that this isn't the place where your bridge is going to be, or that you don't want this actual shape. You know, I've got this kind of S shape that's occurring. If you ever want to change that, you have to completely come back in here every single time and change all of those values, and then also change and resketch your bridge. But once you have this established, you could come in here and edit the shape, give it more thickness somewhere, and then also change, if you did change the location of it, you would change the start and end points and the level of your slope arrows. So I'm going to tell you right now that if you can't get your bridge to be parametric to finish out your midterm project, this is your fallback default. Of course, the assignment is to make your bridge parametric, or your tower. So you guys, two guys that are doing towers, you're going to have to adapt this in the vertical direction. And if you still want to get a nice rendering that shows a pathway and you've got your actual railings and things like that, you can model it in this method, but I'm going to take off a few points, okay? In the end, we want to have nice renderings of a bridge, but we also want this to be adaptable, and you're going to talk about how this bridge could be moved to another location and what your rules were that allowed it to actually make it parametric and move and be able to adapt to different situations. I'm going to go back into the site view, and I'm going to delete this actual floor because it's not parametric. We can't add any parameters to it other than what the built-in parameters are associated with Revit, which were those slope, basically the endpoints. Another thing that we can do is, now that we have a site, we could actually start to model this within the conceptual design environment or the family editor, or we could actually model this in place. Now that we're in the project environment, if you go under home, if we go into massing and site, you see that there's an option here called in-place mass. If you click on this, and it's going to give you this little warning telling you it has to enable, turn on the mass in this view. Just hit close. You're going to give this particular mass a name, so we might call this bridge path. Once we do that, we go into this sketch mode. So here we are in the project environment. We can see our topography, and we can see all this, additional annotations that I've already set up. But look at what happened to the top tool ribbon. You should see something kind of familiar where we've got a home, your inserts, your view, manage, and modify. And under home, you have your components, you have your different work planes, and then you have your additional drawings, drawing commands, including your points. We can also click on properties and make family types. And we're basically within the conceptual design or conceptual massing environment overlaid on top of the project environment. So we're kind of in the same family mode that we've been working in. It's just we're now also within the project environment, meaning that once we close out of this, so if I finish this mass, we come right back into the project environment. Make that again, bridge path. Once we've made that, if you look in your project browser, you've named your in-place mass, you can expand the family section and then go down under mass, and you should see your bridge path is already kind of loaded into the project, if you will. Now, everything that we're about to do, I'm going to actually switch into the conceptual design environment because that's what we've been working in. But everything that we do from here on out could actually be done right here in this environment. The reason that I'm not going to do it in this environment is that you have to be careful of what's underneath this sketch environment. You can actually see that you can access and actually snap to different parts of this environment. And if you remember, when you set up parameters and constraints, if you don't snap to the right point, you get all kinds of error messages that pop up, or things that work in ways that are unexpected to what you were actually thinking they were going to move in a certain direction. You could accidentally snap to, let's say, a topography point, or one of these control points, or something else that's already in the project environment, and you'll get all this erratic behavior in your family environment. So I'll caution you on, actually working in that mode, but that is an option. Another way would be that if we actually have our site drawn out, I've sketched out kind of this conceptual path of what I want to model. We could go into the applications menu, and before we do that, I'm actually going to hit visibility graphics, so VG, and I'm going to turn off the topography, because really what I want is this path and maybe the position of where these points are going to be that I can parametrically control. For those of you that don't remember, type in VG. If you're in the sketch mode, that you might want to cancel your mask. So type in VG and then turn off your topography, because all I want to see is all of those annotations that I've already created. And in the applications menu, I'm going to go to export CAD formats and then click on DWG. And ignore that error and just hit close. And you should get this dialog box that says DWG export. And it'll give you a little preview of what you're exporting. So it should look like the screen that's behind it. I was in the site plan view. I turned off the topography and visibility graphics. Then I went to the applications menu and clicked on export and then DWG, or CAD formats DWG. So once we're in this mode, you can click on all these different settings. I'm not going to go into it, but you could click on this ... button, and this is where you get all the different ways of how you could export this into a CAD format. I'm just going to leave the defaults alone, and we're just going to hit the next button. You all right? Did you get that broken chair? Yeah. Careful. Once you do that, you should get an export, and it'll default to some target folder. It's probably going to default to wherever you opened your tutorial file. And just by default, I'm going to save the file name as is. It's a long file name, but it's called Bridge Tutorial Project File Site Model. And then it says Floor Plan Site. Basically, anything you export out of Revit, if you have this export views on sheets, or actually, sorry, the naming as automatic long specified prefix, is going to take whatever your file name is and then attach a suffix to it, which happens to be the name of whatever your floor plan and file name, or the floor plan datum. So it's doing floor plan and then site. We could change this to be a short name, and it will just do floor plan site. It doesn't really matter. And I'm going to hit OK. Mine says it already exists because I've already done this. I'm going to hit yes. Should take a minute to export. So now what I'm going to do is go into our view, user interface, recent files, and we're going to start a new conceptual mask. And actually, to speed things up, go ahead and close that, and we want to open a family. And that other file that I told you to download should be called, we'll find it here. Go back to those files that we just downloaded, and it should be Bridge Tutorial Family File Bridge Path. Go ahead and open that up. It should be a blank file. Essentially, this is similar to if we just opened up a new conceptual mass. But you're going to notice when you hit the family types and properties, I've already entered in a bunch of parameters. Nothing set yet, but we at least have all the different data and parameters that we're going to be using. This way we don't have to like spend probably 15 minutes creating all of these. Now if you click on the floor plan and then level 1, I'm going to click on Insert and then Import CAD. We want to import that CAD file that we just exported. We want it to be current view only, so check that box. I don't want this to show up in every single view that we have in this particular file. Positioning, I'm going to put it on origin to origin, and keep the colors. We can preserve the colors. Everyone have those different selections. What I'm showing you here is we cannot copy and paste information from a project environment into a family environment and vice versa. So in order to work between the two environments, if you have something that you want to actually trace over that was done in the project environment, that had a particular site and a context to it, a particular scale, we have to always export it as a CAD file and then import it into our family environment as a CAD file, as a background. So when we hit open,
It won't let me select current view only.
It could be in level 1.
yeah, make sure you're in like level 1 floor plan, where you're in a 3D view. And so it will bring in this symbol. Remember, everything's called an import symbol that looks like the CAD file that we exported. So now we have something that has some relationship to our project environment. It has actual scale. The scale meaning that it has the actual dimensions that we drew on top of our topography. This will make it so that we can, when we actually build this path file that's parametric, we're actually working with a scale that is already in relationship to our project environment that we're already working with. I'm going to click on this import symbol, and you'll notice that you get this little pin symbol. We want to click on that, what's called unpinning this particular DWG file. Basically, you can't move or do anything to that file until you unpin it. It kind of locks it into place. You can also click on unpin and then pin it back. You can do whatever you want there, but we need it unpinned. And I'm going to move this curve 1S, so snap to that point. And we're going to move it to the intersection of these reference planes. Those reference planes are those dashed lines that are in the conceptual mass. And then I'm going to also rotate it so that this endpoint is horizontal, or parallel to this horizontal reference plane. So with the symbol selected, click on rotate. And remember, the rotate command by default wants you to rotate about the center. We have to drag that center point and then make it snap to our intersections of our reference planes. And then I'm going to click on this angled line that connects from the start point to the end point. And then the next time I'm going to click is going to be the horizontal reference plane. That'll rotate it into place so that we're actually working with, kind of 90-degree angles that we can measure. This is the exact opposite of what we did when we placed the bridge path last time. When we brought it into the conceptual or the project environment, we placed it there and then, rotated the conceptual family into place.
Do we want to pin it
You don't need to pin it, you can keep it unpinned. And you might want to save this. I'm going to do a save as family. And I'm just going to give it another name like version v1 or something. You can just overwrite your file. Doesn't matter. Now if you click on the family types under properties, so you get the dialog box that pops up that shows you all the different parameters that I've already programmed into this bridge file. You should see a similarity in the naming convention to what I've named these points along this path. So I've got a curve 1M, I have a curve 1E, a curve 1S, then I have X, Y, and Z associated with all of them. I've also have some additional parameters that I've programmed in, and I've separated them out a little bit, organized it, so that all of my points, which are going to represent the X, Y, and Z, are under data. Then I have some analysis results, which are a slope angle, a bridge total rise. Then I have some dimensions that are curve 1 length, curve 2 length, and then the overall bridge length. Then I have some constraints that are, there's always a default elevation that's already programmed into this file. But then I added a couple more that say the bridge spot elevation start and the bridge spot elevation end. To make this parametric, this is something that you guys have already kind of done in many different iterations and assignments. I'm going to place some points, some point elements. And right now I'm just going to place them randomly near all of these different points that are along this bridge. I'm not going to worry about those curve 2 center points. I don't think we're going to need those. So I just have them along this kind of S path. I placed all of those points and now I'm going to select them and then turn on the reference planes for each of those points. So always, click on always. You can see for some reason that the actual planes don't come on, but if we go into the 3D view, you can see those X, Y, and Z planes associated with each of those points. If we go back into level 1, I found that it has to do with the fact that we have an imported symbol. I think if we turn on our wireframe view, you can actually see those planes again. If you don't see the show always, that's okay. The next part is we're going to dimension some X, Y, and Z dimensions from these reference planes to these points. So I'm going to start with curve 1S. And with this vertical plane as a starting reference point, I'm going to dimension to this first point. I'm going to do the same thing from the horizontal plane. Let's go ahead and do that for each of these points. So what we're trying to do is establish you know what, don't do that to the midpoint. I'll tell you why in a minute. Just do it to the endpoints. Just do it to the this first start point and that very end point. And I'll tell you why as we progress. Instead of doing every single point, which is where I think a lot of you start running into overly constrained error messages that come up once in a while. Have anyone gotten those messages?
Yeah.
I think we all have. I'm going to make the points that are in between relative to basically the start and end points. And we'll go over that in a minute. So this curve 1s, I want to change that dimension in the horizontal. Click on the label. I want that to be the curve 1s x, and the next one will be the curve 1s y parameter. And then if you click on that point, change the offset, make that equal by pressing that button over in the properties bar. Make that equal to curve 1s z. So remember we plotted in earlier assignments our x, y, and z of every single point. That's what we've done for this one particular point. You're going to do the same thing with that end point. So that overall horizontal dimension will be equal to curve 2EX and curve 2EY is your vertical. And then clicking on that point, click on offset and click on the button and make that curve 2EZ. Everyone get those set, those different parameters equal to those dimensions?
When you were measuring, did you measure to the plane or to the point?
You should have measured to the individual reference planes that were associated with each of the points. So I made sure I snapped to that dotted reference line, and then you should see the highlighted reference plane of each of those points.
Okay.
So now I'm going to turn on my properties, and I want the curve 1s, the x and the y, they should be set to some random dimension, dimensioning where that point occurred in space. Just go ahead and set those equal to the sy and the sx to 0. Hit apply. That point should move to that, basically the origin point. But the reason why I set this point off into space first and then moved it was that later on we can now move this point in the x and the y away from the 0 plane. If we set that somewhere else, we wouldn't have been able to set, it would have been snapped to the 0, 0 point, and we wouldn't have been able to set those dimensions. I'm going to hit OK so that that kind of enters into the memory of the computer. And if I zoom out just a little bit here, you should see these dimensions down at the bottom. And one of them here is set to the overall length says 1,643 43 feet 8 inches. That's what I'm going to set my curve 2E in the X value to be set to 1643 feet 8 inches. And hit apply. And then since that Y is also set to the horizontal reference plane, I want that to be set to 0. Everyone get all that entered in? All right. So, one thing I just thought of is that our bridge length parameter that I have programmed in is actually going to be the same thing as this dimension that we just typed in that said that's equal to curve 2EX, right? Assuming that our start point is always going to be at 0, 0. So what I actually want to do is change my bridge length. I'm going to type in that value. And I'm going to make my curve 2EX equal to the bridge length. It's kind of redundant, but what I'm saying here is that what I want someone to do when they open up this file is only really enter in information under this dimensions section. And so it makes more sense to somebody who hasn't seen this file before, who opens it up, that says, okay, how long do I want my bridge to be? I want them to type in under bridge length what that actual length should be, instead of trying to figure out which of these parameters under data they should be manipulating. So we'll go ahead and do that. I'm going to hit save. The next thing I'm going to set up, and maybe what we want to do is test our parameters real quick, the ones that do work. So click on bridge length and hit Control C so that we can copy the 1,643 foot 8 inches. Do Control C there. And then I'm going to type in, let's say, 2,000 feet instead and hit apply. And I want to make sure that my point moves further off to the left when I hit apply, so I know it's working. The reason I did the Control C is I want to remember that actual value before I change it. I want it to come back to that value. I can hit Control V. And we stored that information in the computer's memory and then pasted it back in so that after we tested that that point moves, we can move it exactly back into the right location. You'll notice that there is no undo when you're in this parameter dialog box. And so I use the Control C, Control V as my one undo that I could possibly do at a time. So I just wanted to test it out and make sure it works. I hit OK. So that's good. The next point that I want to make parametric, and I want it to have some relationship between the overall length of this bridge. You can kind of see this dimension background in this CAD file that I have is kind of my map of what I'm thinking is going to have some relationship to one another. What we had done before in a lot of our assignments is we did everything relative to this 0, reference plane, which means if you had a bunch of different points, and if they're all relative to this reference plane, you probably know by now that if you want your bridge to stretch, you had to change all of your individual points, right? Or come up with some formula that changed them relative to one another. I'm showing you that maybe we need to take a step back and pre-program a bridge that has points that are all relative to one another. Our relative points in a bridge are going to be your start point and end point, and then everything in between needs to have some relationship to those end points or start point. So if you look at my dimension, I've got this overall dimension, and then I have two curves. I have this one I'm calling curve 1 that kind of curves up, and the other one that's longer and curves down is called curve 2. I have an individual dimension for each of those. One is saying 563 feet 1 inch. The other one is 1,080 feet 8 inches. But underneath it, I have a ratio that I've set up that basically would take, if you were to divide 563 feet 1 inch divided by the overall length, you'll get this ratio of this decimal value of 0.343, and then same thing with this other. Basically what I want to do is establish a rule that says at this point, no matter how far this bridge stretches, this point is always going to be at this normalized value of 0.343. So in order to do this, we're going to set up a dimension string, and we could actually come off of the start point or this reference plane and go to this point. So I made a dimension string there. Now I'm mostly going to make a dimension string from the horizontal plane to this point so that we could eventually locate it some distance off of the reference plane as planned. What I'm going to do is zoom in so I remember this value on these dimensions down at the bottom. I'm going to click on my family parameters and make it so that I can see this number. Actually, I need to also see what the name of that point is. The name of that point is actually curve 1E. Stands for curve 1 endpoint. And I want the x dimension, so if I go to curve 1E and then the x dimension, I actually want this to have a formula that would say, take the overall bridge length, so type in bridge length, and my bridge length parameter is called bridge underscore length. And I want to multiply that by 0.343. Hit enter.
How did you get 0.343 number?
If I did this manually beforehand in a calculator. I said in this plan where that point is located is at 563 feet 1 inches. I typed that into the calculator and then divide that by the overall length. Gave me this decimal point, this decimal value.
So it's basically like a percentage of how far.
Exactly. So I always want this point to be 34.3% along its length. Now, of course, you're going to get some other value here. Let's see, what is that? It says 563 feet, 9 and whatever, hit OK. Yeah, I probably rounded these dimensions. Actually, these dimension strings, I didn't go over dimension strings, but in the project environment, I actually rounded it to the nearest 1 inch, so it probably is truly some other random number there. I'm not going to worry about it too much. I'm going to click on this dimension string that we just created and make that equal to our curve 1 EX. So it should move relatively close to these little crosshairs that I've already created in the CAD file. The next part is I've got this dimension that says 11'7" for this point. I'm just going to hard code that into the y dimension of that point. So the curve 1 EY, I'll just type in 11'7" and hit apply. And nothing will happen because we need to also come back over here to that dimension string and then make that equal to curve 1 EY so that that point moves. Really those y values have not a whole lot of relationship at the moment to anything, so I'm not going to worry about that. That has no built-in calculation. But now that we've entered this information in, if we click on the family types and then go ahead and change our, again, do a Control-C on that bridge length, and change this to something like 3,000 feet, and hit apply, you should see that point move in relative position to the overall length of the bridge. So I'm going to go back and type my bridge length back in, or Control-V it. So I know that that works. I don't need to make another dimension string that would tell me where this point is in relationship to the end point. I don't need to enter in this dimension of creating another value that would have some dimension divided or times the 0.657. If you made another parameter that did that and made it snap to this point, you'd get an error message that says your constraints, or you've overly constrained the sketch, meaning you're putting two dimension strings trying to define the same exact x position of that point. If you ever get that error message, it's probably because you've got two dimensions trying to actually snap to the same point. A lot of you have probably got that when you maybe did a z dimension and then you also did an offset. You have over-constrained the sketch by basically doing a double set of dimensions to that value. The next points that we're going to do is in between. I'm going to do the same thing, but now they're going to be in relationship to either the start point or the end point, and in relationship to your curve length. So I need to define what curve 1 length is and curve 2 length is. Well, our curve 1 length is actually that same value that we just created. So I'm kind of working a little bit in a loop here. But if we go to curve 1 length and type in, let's go to curve 1 EX. Actually, no, sorry. Curve 1 EX is actually the same as the curve 1 length. So, do I let's just copy that equation in the curve 1 length. I'm going to have kind of redundant values here, but it's all right. So I made curve 1 length is bridge length times the 0.343 in the formula, and then that curve 1 EX is equal to curve 1 length. Because I can, let me test something real quick. Yes. So if I wanted to, and the reason I'm doing that in kind of a redundant way is that because I've set up this relationship with the dimensions, if for some reason later on I decide I know what curve 1 length is going to be, and not maybe the overall length of the bridge, I could also come into curve 1 length and type in, let's say 600 feet, and you should see my bridge length formula changes or calculation, because it's entering in this information and then forcing bridge length to then respond to whatever I actually enter into that dimension.
Okay, so that's why you went and had it all relative to that first point.
Yeah. So it really doesn't matter, but I guess what I'm going to be doing is saying that the user or whoever takes this bridge has the ability to change 3 values. You could change the overall bridge length, you could change the curve 1 length or the curve 2 length, and everything should respond all relative to one another. My next point that I want to establish, and I just need it for the formulas, as I just told you, we don't need to enter in this data of the rest of basically what curve 2 is, but I do need it in the parameters so that I could use in formulas in a little bit. So that curve 2 length should be equal to what? We could do it that way, or we could just say, to make sure that we don't over-constrain our sketch, I'm going to do the bridge length minus that curve 1 length, just in case I had some hidden rounded value in there that I didn't account for. This will always ensure that my curve 2 length is always whatever's left over. And it will gray out because basically I'm not going to be able to edit that formula. And my curve 2, no, I don't need to do anything there. Okay, so hit OK. The next part that I have left to do are those 2 points that are in between, are basically some ratio located in between the curve 1 length or the curve 2 length. So I'm going to set up another dimension string, again in our x and y dimensions, to that curve 1m, and I'll do the same thing to the curve 2. Now this point, for the curve 2, we actually want it to be, I guess it doesn't matter, but let's go ahead and make it relative to the end point. Do we want that? Wait. Or we can, let's make it strike from the, okay. Curve 1 endpoint. We zoom in on that point and snap to the vertical horizontal plane, or the vertical plane of that point, and strike our dimension to this midpoint. That will be our relative datum for the x position of that point.
To the one that you created, or to the point? Like to the crosshair one, or to?
Not to the crosshairs, to the actual adaptive
actual point,
the
okay.
reference point. So So now this point for curve number 1M, I'm going to set up a similar formula. I'm going to zoom out a little bit here. But this time, this curve 1M in the x dimension is going to be our curve 1 length.
You're typing in curve 2.
Thank you. Alright, curve 1mx, there we go. Gotta keep track of your parameters. Note to self. Curve 1 length, and then multiply that by, now I've got this value down here in parentheses, 0.513. I'll hit OK, and then we can change that dimension string to equal curve 1 mx. I don't care that they're not hitting these exact points for some reason in my crosshairs, because we're just making everything relative to one another. This other point in the y dimension, let's just type in the 102 feet 7 inches. So curve 1 my will equal there's my curve 1 EZ also, that needs to be at 0. Don't worry about that at the moment. And then change that dimension to equal your curve my. Should be pretty self-explanatory. We're just plotting out the x, y, and z of this point. Where are we stuck at? Huh? Okay. Okay, so this next point, so why did that move?
Why did that move?
I accidentally have this snap to the wrong parameter. Both of my points moved, if you noticed. They moved up in the y direction. That's because I wasn't paying attention, and I've got curve 1 my, and this one is also equal to that same parameter. This should have been curve 1 ey. Now this next point that's over here, in between curve number 2, let's zoom out a little bit. That is our curve 2m, and that x dimension is going to be equal to our curve 2 length. This is why we needed that information, times my little value that's down here, the 0.498. My y is going to be equal to this 170 foot 7 inches. Again, this is, if you just zoom in on your points, I've labeled them what they should be. Those are equal to your parameters. And this will be equal to 170 feet, 7 inches. and then set your different dimensions to those parameters. So now, when I change, I'm going to zoom out here. I'm going to click on this symbol, or basically our CAD file, and use the sunglasses and temporarily hide that element.
Where is that dimension line for curve 2M in the X dimension? What's that snapped to?
Should be snapped to the, let me turn my, so this curve 1 end point, you want to make sure that you're snapping that dimension to the vertical plane of that adaptive point, and then that goes to the vertical plane of this midpoint of curve 2. Basically, we're making it relative to the endpoint of curve 1. Now I'm going to hide this element, click on Properties, and change my overall bridge length. I'm also do that Control-C again. And type in another value, maybe like 2,000 feet, and hit Apply, and you should see all of your points move relative to one another. So it shouldn't matter how small you go. You could go down to 500 feet. Everything is going to move with those percentages relative to basically that start point and then also the end point of curve 1. Before I exit out of that, I'll do my Control-V and get my bridge length back to our sketch. Okay, we've just done that with these points that are associated with the center line of this bridge. The next class, we're going to build upon this and make an offset. We don't necessarily need to make all of these points offset, but we're going to make a thickness of a bridge that's going to sweep along a path that will follow basically this whole entire scheme that we just created. And all we now need to do in order to scale a bridge across a river is know at this particular moment what the overall bridge length needs to be. We don't have to know where each individual point is located along that path, which is where we kind of have gone in the past, which might be making a lot of work for everybody. So some of you might have like 10 different points along a bridge path that you had to enter in each X, Y, and Z to make it stretch across a river, and maybe you haven't done that yet. But if you were to go back and program, think of it in some kind of relationship to a beginning point or some points along the path. We could change one parameter and then have this thing respond across the topography.
So essentially, if we have, because the shape of my bridge path is fairly similar to the one that we're working on here.
Okay.
If I were to use the scale that I established in my model, in my analog model, and measure that distance, set that as the initial bridge length, and then plot points that kind of correspond the way that these do to that new distance. Basically plug those distances into the points.
And then you can type in one value, which is your overall bridge length, and you are essentially scaling that bridge. So basically, if you kind of take a step back, which we just did here in class, and look at your bridge path, and you can establish that scale based directly off of your analog model again, is going to be based on, all those points in between are based on ratios. Some kind of value in between, 0 and 1 that would tell those points where they need to be when that bridge stretches back and forth.
I have a question about scaling. Like, we're scaling the length of the bridge back and forth, but are curves staying the same? So I'm wondering, are we gonna have to, like, what's gonna happen to the curves, basically?
So basically right now we're actually kind of stretching and scaling it in the X dimension. We're going to program in a little bit more as we build upon this, how we could establish how you would scale in the Y, so you can keep the same shape. But when you stretch across a river or some dimension, you might decide that you don't exactly want it to scale equal on both sides.
Yeah.
So what we'll do is we'll build upon that in the next tutorial. Plus we're going to add in the slope. So we have to think about trigonometry a little bit. Remember in my last class, I already had that programmed into the bridge, and a lot of you commented that you couldn't figure out what I did. I'm going to walk us through how we can get this to slope, and knowing some trig functions, basically knowing how to come up with a tangent. We all should know a little bit of trigonometry because we're going to be architects, right? So we can know, if we know a little bit of tangents and how to find angles, we should be able to find the overall rise of the bridge. So if we know the start spot elevation, the end spot elevation, we establish an overall rise, we should be able to find the overall rise of each of these points of where they occur along the path so that it's sloping in the Z direction in a consistent manner across the bridge.
I get that, but what about the curves that we built, like the
The canopies,
and all
that's
that?
tutorial number 2/3.
Okay.
We're going to be building this, we're doing the path, we're going to build this path, we should be done with it halfway through next class, and then we're going to bring in some canopies and then talk about how we can scale that.
Okay.
We're going to build, basically by the end of this tutorial, 3 classes, takes us to spring break, you'll have a bridge that we've built here in class that should mimic something similar to what you guys have been working on in class. So your assignment for, what is it, Thursday now? So for Tuesday, I'm kind of backwards now because I missed a day, is to go back and look at your bridge. And some of you might already have those values programmed in because you did your X, Y, and Z already programmed in to all the individual points. I don't care which way you do it. You could look at your parameters, you could look at what you wrote down, or you could just go back and measure your bridge again. Take your path and get some kind of center line established of that path that has points established that can grow at least to what we've done so far in the X, Y, and actually just in the X. We've kind of just established an X at the moment. And then just upload that and get it so that this is all relative and can span across some distance, and you can just enter in one bridge length and the whole thing adapts. Okay? Let me talk to you in a minute. And then Alexander, you had some questions as well. Anyone else need me to kind of come around and talk to you for a minute?
I do.
Okay. Alright, what's going on?
Okay, so
Well, let's go back. Did you understand everything? Whenever you
I got lost.